Hello friends, in this tutorial we will try to see how to purify a protein, and in this tutorial your protein has been expressed in E. coli cells and it has a hexahistidine tag in its N terminal. So most examples which I'll use in this tutorial is about a 14 kilodalton protein which has been expressed in BL21 star cells using PET28A vector, so it contains a hexahistidine tag in its N terminal. The protocol which I'll discuss here is a very generalized protocol and it can be implemented to any protein. Although protein purification protocols vary from protein to protein, some protein are relatively easy to handle compared to others. So in this tutorial I assume that you already have expressed your protein in E. coli cells. First step of protein purification process involves preparation of cell lysate. This cell lysate is centrifuged to remove the cell debris, and supernatant contains your dissolved proteins. And this supernatant is used in nickel affinity or size exclusion chromatography to purify your protein. The steps for membrane protein purification are quite different. The protein which I am discussing over here is a water soluble protein, so the steps in this protein are different. So I assume that the protein which you have expressed for your purpose is water soluble protein, and in this tutorial I am discussing water soluble proteins. So before going ahead with the preparation of cell lysate, it is very important to decide on your lysis buffer, because if later you realize you want your protein in some other buffer, then you end up doing multiple buffer exchange steps and you lose your yield in that case. So it's better we decide beforehand what should be our lysis buffer. Another reason is solubility and stability of the protein, which is very important, because if you are working on some difficult protein, then probability is high that instead of coming in the supernatant, your protein will go into pellet, that is, it will precipitate while purification process. So if you haven't decided your buffer properly, then your protein might go into precipitate rather than staying in the supernatant. So it is very important for our case to decide properly on what type of lysis buffer we are using. So before deciding on your lysis buffer, it is good if you decide on your buffering system. So buffer system is the part of the lysis buffer solution which stabilizes the pH of the lysis buffer. Most common buffer systems which are used for protein purification are tris HCl, phosphate buffer, and heaps buffer. There are several other buffer systems also, but these are the most common ones which are used. And your protein might be stable in some buffer systems, might not be stable in some other systems, so you need to check on that. And while deciding your buffer system, you also need to take care what you will be doing with your protein in the later stage. For example, in the later stage, if you want to do SPR analysis, then you might not want your protein in tris HCl, because tris has amine groups and they can hinder with your SPR analysis if you want to immobilize your protein on SPR chips using amine coupling. So another thing is, if you are working on metalloproteins, then phosphate buffers might not be good for you, because they hinder with the stability of the metalloproteins. So it is important you decide on your buffering system properly. Another important thing is the pI of your protein. Isoelectric point, that is pI of the protein, is the pH where the overall charge on your protein is neutral. The problem with pi is that the solubility of the protein at pi is minimum. So whenever you are doing any purification process, you want to stay away from your pi. So if the pi of your protein is around 8, that is pH 8, then you want to do your purification either below 8 or above 8. Since above 8 will be too much non-physiological condition, so it is better you stay 7 or 6 pH. So in your lysis buffer solution, another important part of are the buffer additives. So one was your buffer system, other are your buffer additives. Buffer additives usually help in increasing the solubility and stability of the protein in the lysis buffer solution. Most important additives used in lysis buffer solution are salts like sodium chloride or potassium chloride. They are usually used between concentrations of 50 millimolar and 300 millimolar, depending on the type of protein you are working on. If you are working on metalloproteins, then you need to use respective metal ions in your lysis buffer solution. So if your metalloprotein has magnesium ions, then you need to use some magnesium salt to stabilize your metalloprotein in the lysis buffer solution. Another important part of your lysis buffer solution is our detergents. So detergents usually help in solubilizing the membranes of the cells, E. coli cells, which are where your protein has been expressed. So they are usually the most common detergent which is used is Triton X, and it is usually used in concentrations of 0.1 to 0.3%. Another important part of lysis buffer solution are protease inhibitors. So proteases are the proteins in the cells which chew upon your unuseful proteins, and they are also released along with your protein of interest in the lysis buffer solution. So there is probability that they will hydrolyze the proteins, your protein of interest. So it is important to use protease inhibitors. Most commonly used protease inhibitors are EDTA and PMSF. And also there are protease inhibitor cocktails available from vendors. EDTA should be avoided as protease inhibitor cocktails if you are using nickel affinity step in the later stage of your protein purification, because EDTA chelates with the nickel, so it can affect the nickel affinity purification process. So EDTA should be avoided in that case. Other important additives which are used in the lysis buffer solution are reducing agents like DTT or DTE. They help in reducing the oxidative damage done to the proteins, and oxidative damage can occur to the thiol groups of your protein, and it can affect the stability of the protein. If your protein contains disulfide bonds, so it is suggested not to use DTT or DTE, because that can hinder that can affect the structure of the protein and overall stability of the protein. So here is an example of a cell lysis buffer solution. I have used 50 millimolar tris pH 8.8. Since the example which I am showing here, the 14 kilodalton protein has a pI at around 7.5, so I have used pH 8.8 here. I have used 150 millimolar NaCl, which will help increasing the stability and solubility of my protein. I have used 0.1% Triton X, which will help dissolve the membranes and bringing the protein into the solution. I've used 1 millimolar DTT, which will help reducing the oxidative damage to my protein. 5% glycerol will help in increasing the stability of my protein in the solution. I have avoided any protease inhibitors in my case, but they should be used most of the time. Since I'll be doing nickel affinity, I have avoided EDTA. PMSF can be used even if you are doing nickel affinity in the later steps, or there are protease inhibitor cocktails available from commercial vendors. These cocktails comes with both EDTA and without EDTA. So if you are doing nickel affinity step, you can use protease inhibitor cocktails which do not contain any EDTA. So after you have decided on your cell lysis buffer solution, these are the steps which needs to be followed. First, you need to harvest the cells by centrifugation at around 2000 G for 5 minutes. Then you need to dissolve the cells in the lysis buffer solution and keep them on ice for 20 to 30 minutes. Later step involves cell disruption by either sonication or by French press or by enzymatic treatment or by freezing and grinding. These are the steps which I will be discussing in the later part of my video. Thank you.